In this video, the learner will multiply and divide radical expressions and rationalize denominators to simplify radical expressions. So first, let's take a look at multiplying radicals. We have what's called the product property. When we have the square root of a times the square root of b, we just multiply what's underneath those radicals. So that becomes the square root of ab. Also, on the other side of that, if we have the square root of a times b, we can separate that into two radicals. And if they're a coefficient, it's always outside times outside, inside times inside. So when we have a root b times c root d, a and c get multiplied together, and b and d get multiplied together and stay underneath that radical. So see here, we have the square root of 3 times the square root of 5. So 3 times 5 becomes the square root of 15. Or the square root of 26 can be broken up into the square root of 2 times the square root of 13. Notice here we have some coefficients, so we have 2 root 3 times 4 root 6, and that becomes 8 root 18. And of course that 18 could be simplified further. So here we have 9 root 2 times 2 root 10. So we would multiply 9 times 2, outside times outside, and inside times inside. And that would become 18 root 20. That square root of 20 needs to be simplified further. So we break up the 20 into 4 and 5 and take the square root of 4 out and multiply that by the 18. So that becomes 18 times 2, which is 36, root 5. For 3 root 3 times 4 root 6, the outside times outside is 3 times 4, inside times inside is 3 times 6, and that becomes 12 root 18. The square root of 18 can be simplified further. We would break that up into 9 times 2. The square root of 9 comes out as 3 and gets multiplied by that 12 to be 36 root 2. Next, we want to take a look at what happens when we multiply by 1. So what do we get when we multiply 5 times 1? And of course we know that answer is 5. What if I changed what 1 looked like? So instead of just multiplying by 1, what if I multiplied by 2 over 2? Which of course 2 divided by 2 is still 1. So I'm really just still multiplying 5 times 1. And that's still going to equal 5. What if I took that same 5 and then multiplied by root 2 over root 2? Again, this is just 1. It just looks a little different. So I would still have 5. So we know that multiplying by 1 does not change the value of a number, even if the 1 looks a little different. We're going to use this for what we do next. When an expression has a radical in the denominator, it is not completely simplified. And so what we have to do is rationalize the denominator. So first what we're going to do is simplify as much as possible. Then multiply the fraction, both numerator and denominator, by the term that is still in the square root in the denominator. And then simplify and reduce. So for example, we have 5 divided by root 7. This is not simplified because root 7 is in the denominator of this fraction. So what I need to do is I need to multiply by something that's not going to change the value, but changes what this looks like. So in order to do that, I'm going to multiply by 1. But the 1 I'm going to choose looks a little funny. It's the square root of 7 over the square root of 7. When I do that, I multiply straight across for those fractions and I get 5 root 7 over the square root of 49. Well, the square root of 49, because 49 is a perfect square, is just 7. So now by rationalizing that denominator, I no longer have that radical sign in the bottom. So my final simplified answer is 5 root 7 over 7. Let's try 4 divided by root 3. Again, I don't want the root 3 to stay in the denominator, so I need to rationalize that denominator by multiplying by 1. The 1 that I want to choose here is root 3 over root 3, because that's the value that's underneath that radical. That's what's going to help me get rid of that square root symbol. So multiply straight across and we get 4 times root 3, 4 root 3. Square root of 3 times the square root of 3 is the square root of 9. Of course, the square root of 9 is just 3, so we're left with 4 root 3 over 3. I have 2 examples down here I'd like you guys to try. I want you to rationalize each of these denominators.